Good afternoon, sir.
Good morning, sir.
Good morning.
सर वेळ का तू
हो सर, होत आहेत जॉईन. आपण वाट बघू विद्यार्थ्यांची. वी विल वेट फॉर फ्यू मिनिट्स टू फॉर द स्टुडंट्स टू जॉईन.
ओके.
I think sir has joined just now.
Okay, okay. I making him co-host. Surgaya sir.
Yes, sir.
Hmm.
Yes, sir. Yes, sir.
Good morning, students. This is our 13th day of Sir C. Raman lecture series. From today's lecture, we have a guest lecture of from Professor Rohan sir. With I welcome you all, and I invite Dr. Professor Ambore sir to introduce Rohan sir. Please, sir.
झालं नाही काय
Thank you,
Ambore
Kharat
sir.
sir.
Yes, sir.
Hello, everyone. Today, it is my great privilege to introduce today's guest speaker of this Sir C.V. Raman lecture series organized by Department of Physics, Vinayak Vignan Mahavidyalaya, Nandgaon, Khandeshwar, Amravati. I would like to.
Hello, Ajay sir.
Yes, sir.
Hello.
Yes, sir. Hello.
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 सर आवाज दोघांचा आवाज येतोय सर. हॅलो.
Hello.
Sir.
Hello.
हा शिरसाट सर तुमचा येतोय आवाज.
Hello, sir.
हा सर हॅलो बोला.
Hello.
हो सर येतोय सर तुमचा आवाज.
Hello, sir. Mute. Mute.
अंबोर सर.
हॅलो एव्हरीवन.
सरांना कॉल करा.
सर देर इज सम टेक्निकल इश्यू कनेक्टिव्हिटी इश्यू ॲट शिरसाट सर्स साइड. त्यांच्या साईडला थोडासा कनेक्टिव्हिटी इश्यू आहे. ही
Okay.
जस्ट नीड 2 more minutes.
ओके.
थोडं ब्लूटूथ कनेक्टिव्हिटी आहे. आपला आवाज त्यांना ऍक्च्युली चाललेला नाही आहे तिकडे. त्यांचा आवाज आपल्याला क्लिअर आहे.
ते ऑडिओ यूज ऑडिओ करा. ते हे केलं सर.
खरंच सर तुम्ही
बोला
त्यांना कॉल करता का तिकडे?
माझ्याकडे नंबर नाही त्यांचा.
आय विल गिव्ह यू हिज नंबर.
Okay.
प्रॉब्लेम असा होणार की मी कॉल केल्यानंतर माझं नेट डिस्कनेक्ट
ओके
होऊन
ओके.
जाणार. सांगू ना सर नंबर
सेट.
सेंड करू. ओके.
हो.
अंबोरे सर.
हो सर.
हा सर.
हो सर बोला सर.
तुम्ही डिस्कनेक्ट व्हा,
ओके
सरांशी बोला आणि मग पुन्हा जॉईन व्हा.
ओके ओके.
चालेल चालेल काही प्रॉब्लेम नाही.
ओके सर. फोन दिया. मोठा वाला. कांग्रेस डिलीवरी वाला.
हाँ बोले सर, प्लीज प्रोसीड.
येस सर.
सरांचा माईक सुरू झाला सर.
सरांचा माईक बहुतेक ऑफ आहे.
हम्म.
शिरसाट सर विल कॉल यू. खरंच सर.
ओके.
He asked me your number. I have given your number. Will call you. He is joined here actually.
हो, त्याचा माईक पण व्हायला चालू आहे. फर्स्ट माईक आला उजवाला.
Hello, sir.
Yes sir.
You are audible, sir.
Hello.
Yes sir, you are audible.
ऐकू येतं, sir.
Minute.
Amber, sir.
Yes sir.
You can proceed now.
सर आपला आवाज त्यांना चालला काही कन्फर्म नाही आहे ऍक्च्युली.
नाही का?
हा.
एक मिनिट.
सर तुम्हाला So, dear students, sorry for the inconvenience. We will begin soon.
Okay, sir. I have discussed with sir. Very soon
Yes,
we
sir.
will join. Sir, you can start introduction. I'll inform to sir for start. Amber sir,
Uh,
please
yes, sir.
introduce me.
Yes. Well, thank you, Karat sir. Hello, everyone. Today it is my great privilege to introduce today's guest speaker of this Sir C.V. Raman lecture series organized by Department of Physics, Vinayak Vignan Mahavidyalaya, Nandgaon Khandeshwar, Amravati. I would like to introduce Professor Rohan Shirsat sir. Sir works as an assistant professor in the Department of Physics at Shankarlal Khandelwal Arts, Commerce and Science College, Akola. Sir has completed his master's from Sri Shivaji College of Arts, Commerce and Science, Akola, and also qualified NET examination just after the completion of his PG, and also qualified GATE in later years. Sir has a huge research and teaching experience of about 8 years. Here, I'm proud to say that Sir was my senior during PG, and Sir is also a good friend of mine. He has supported me a lot during my PG. Even after the completion of his PG, he has guided me for my studies and still guiding me whenever I need him. Well, sir, we are glad that you are here. By not taking much of your time, I welcome Mr. Rohan Shirsat sir for his lecture. Over to you, sir. Thank you.
Okay, sir. I will inform you. You start.
Yes.
Thank you so much, sir. Am I audible, sir?
Yes, sir. Clear.
So thank you so much
Okay, I will
for
make you
such a
co-host.
nice introduction, Ajay sir.
Thank you.
Actually, it's a privilege that Vinayak Vignan Mahavidyalaya organizes a great C.V. Raman lecture series for the BSc student. For the BSc student, it is my pleasure to be a part of such lecture series. So I would like to express my thank you, special thank you to the principal of this college, Honorable Dr. B.C. Ma'am, and the IQAC coordinator of this college, Dr. Khodke Ma'am. I'm specially thankful to the Department of Physics, especially thankful to the Department of Physics who take a lots of effort for such nice activity. So thank you, Dr. Vadadkar sir, the HOD of the Physics Department, and the
Thank
Kharat
you,
sir,
Mr. Thank you.
Dr. Kharat sir, convener of this program, Dr. Professor Ajay Ambure, who is the coordinator of this program. So thank you so much, and thank you Ajay for making me a green leaf of such a huge lecture series. Actually, you are actively participated in all the activities that run by your college, so it is highly appreciable, and your potential made it possible. So we aware our student about thoughts and the life of very great people. So thank you once again. Thank you the whole team who invite me for this huge lecture series. Now, please allow me to share my screen.
Sir, you are now co-host. So you can share your screen.
Is it visible, sir?
Yes, sir.
Yes, sir. It's sharing. It's visible.
It's visible.
Sir, is it visible, sir?
Yes, sir. It's clearly visible.
Yes. Okay. First, now I would like to express my views on my topic, that is nonlinear optics. So here there are some nonlinear optical method, some process of linear and nonlinear, but I have to cover most of the nonlinear processes. So we see here, this is my index of the nonlinear optics. Here we cover some topic like the aspect of wave propagation and momentum conserve, linear medium, nonlinear polarization, second harmonic generation, phase matching, sum frequency generation, difference frequency generation, parametric oscillation, self-focusing of light, and the stimulated Raman's scattering. Now, first of all, we have to understand what is the optics. Now, optics is the branch of a physics that studies the behavior and properties of light. which including its interaction with matter and the construction of instrument that use or detect it. Means optics, it is all about the light. What are the basics of the light? What are the properties of light? What is the interaction of light with respect to medium? It is all about the light. This is the complete study of light. Now we know that light are the radiation which are generated from the lasers. Now, what is laser? The laser produces a radiation, coherent radiation. The laser generate coherent radiation from many wavelength region, from meter wavelength region to soft X-ray region wavelength. But it is not possible to a light to cover all the wavelength because there are many active material present nowadays and laser can be made out of them, but it is not possible to cover the light. But actually, for nowadays it is very necessary to transfer a frequency of light into a desirable frequency light. So this conversion, it is only given by the nonlinear optical process. So actually optics, it is divided by three groups: physical optics, quantum optics, classical optics. But here we have to study the nonlinear optics. It is the subfield of optics. Now first is the linear optics. Linear optics, it is the optics of weak light. Weak light means here ordinary lasers are used, which produces a radiation of in the range of 10 to the power 5 volt per meter, which are very, actually it is very small in nature. That's why we can say that it is the optics of weak light. And actually it is opposite to that of a non-linear optics. In this linear optics, it is consist of, or it is the applications of the linear system. So it is deflected or delay, but its frequency is unchanged. Here means when light is propagated through medium, it generates secondary wave, but both wave have the same frequency and same intensity. So here superposition principle holds. And second, we have to study that is what is non-linear optics. Actually, non-linear optics, it is the optics of intense lights. Whenever an electric field of very high intensity propagated through medium, then the polarization vector, it responds very non-linearly to the electric field, and this is called as non-linear optics. So here we are concerned with the effects that light itself induces, and it as it is propagated through the principle. So here superposition principle, it is not valid in case of non-linear. Now first is, what is the aspect of wave propagation? Generally, when a light is propagated through media, then it is expressed in terms of a wave. We can consider light as a wave. As according to classical physics, it is also found that the light is considered of a wave. And if wave is propagated through any medium, it means that it is expressed by some equation. So suppose consider a plane wave. In such plane wave, when it is propagated through vacuum, then it is represented by general equation that is equal to E naught e to the power I omega t minus kr. Here, k define the direction of propagation of momentum, because this is very important.
Rohan sir.
Sir, please contact Shirzad sir. I think he is disconnected.
Okay, okay, sir. There is some network issue on his end. He will join again.
Fine, sir. Okay.
There is some internet connectivity issue at his side. We will wait for him. Okay. Mm, so, dear students, we are sorry for the inconvenience. Wait for a while.
Hello, sir. This is due to the internet connection problem. Shifter, sir, will join shortly. We are
Yes.
fixing the problem.
Right, right. Fine.
Rohan sir. Hello.
Yes, sir.
Hello, sir.
Rohan sir.
Hello, sir.
Yes, sir. You are audible.
Oh. तो आवाज येते sir.
Okay, sir.
You can start sir.
Actually, I joined it from my mobile. So I share my screen.
Okay sir.
Right, sir.
Okay sir. Uh, there is some network issue from the researchers. We'll have to wait another 5 minutes more.
Yes, sir. Hello, Kharat sir.
Yes, sir. Sir,
सर माईक ऑन आहे का? ओके. सर तिकडे ते ट्राय करत आहेत कनेक्शन रिकनेक्ट करण्यासाठी तिथे. ऍक्च्युली हा प्रॉब्लेम आजकाल सगळीकडेच येतो म्हणून थोडं आपण वेट करू आणि जोपर्यंत नेट कनेक्टिव्हिटी पूर्ण होत नाही, मी सर रेकॉर्डिंग थोडी पॉज केलेली आहे इथे.
चालेल सर, चालेल, काही अडचण
सर
नाही.
मला थोडं रिमाइंड करून द्याल किंवा स्वतःच जेव्हा चालू होऊन जाणार तेव्हा रिझ्यूम कराल, अगर सपोज माझ्या लक्षात नाही राहिलं तर.
येत आहे सर, जॉईन होत आहे.
हो हो.
Hello, sir. Hello, sir.
येस सर.
Yes, sir. Sorry, sir.
दिसतंय सर.
We all are facing in connectivity issue nowadays. It is a common problem. You can continue, sir.
Okay, sir. Thank you, sir. Now I am connecting from my mobile. So this is a wave propagation and momentum conserve. Now, suppose if we are considering a plane wave, and if this plane wave it is propagating through medium, then it can be expressed in terms of this equation. I have already told that E equals to E naught e to the power I omega t minus kr. Now this kr, this k is the direction of propagation of constant, and actually this ijk, they are the unit vector along the direction of propagation. It defines the direction of propagation. Now suppose, now we have to consider, suppose in such case of a isotropic material. Now there is one property of a isotropic material. Whenever an isotropic material, when a light is interact with isotropic material, then what happened? So in case of isotropic material, when light were interact, its properties remains the same. It means that whenever an electric field it is propagated through an isotropic medium, then there will be affection inside that medium. That affection is as per the direction of the incident beam. But when this incident beam it is propagated through medium, then this beam experiences a same refractive index. It means that it experiences a same optical parameter. We can say that in case of isotropic material, the beam experiences propagated along the same direction, so its velocity is also same. Second, in case of an anisotropic material, when light is interact with the anisotropic material, then when light will interact, its property will be different in different direction. Because when an intense light, when it is propagated through anisotropic material, then there will be some affection inside that medium. This affection is as per the direction of the incident beam. But when this incident beam propagates through medium, then it experiences a different refractive index. Different refractive index in different direction. That's why this beam is propagated with a different velocity in a different direction. So in case of anisotropic material, its properties are different in different direction. Now, second, also one aspect of a wave. We know that according to quantum mechanics, light is considered as a photon. Means whenever a photon is incident on the matter, then the material or the molecule of that matter, it absorbs the energy of the photon. And we know that classical mechanics cannot explain most of the effect that were satisfactorily explained by the photon concept on the basis of quantum mechanics. So there is a one relation of a photon in terms of its momentum and the wavelength associated with the wave, which is given by p equals to h upon lambda. Now we know that p is the momentum, h is the Planck constant, and lambda is the wavelength of which is associated with the wave. Or in vector form, we can write out as p equal to h cross into k. Here, k is also direction of propagation. It is important to note that the value of this k means the magnitude of all the value for this k, the significance is same in all above equation. From isotropic material to an anisotropic material to the photon, the significance of k is the same in all above equation. Whenever a light electric field, when it is propagated through a crystal, then its momentum must be conserved. Its momentum means for this, it requires the linear momentum and the parallel momentum. They must be conserved separately. If they constant separately, then the transfer momentum of the wave, it is continuous through the crystal. So it is noted that keeping mind is that key momentum is conserved, but there is no change in the transverse wave of the moment. So this is the aspect of wave propagation and momentum conserved. Then second is linear medium. Now generally the optical media are basically dielectric material. The dielectric material means which do not allow an electric current to pass through it whenever an electric field is applied across them. Instead of that, it get polarized. That's why we say that dielectric is said to be polarized. Because whenever an electric field is incident on the dielectric material, then there will be some affection on that dielectric material. But this electric field, it allows us some forces on the valence electron of that dielectric material. But these forces are very small in nature. That's why they induces electric dipole moment inside the medium. And the orientation of this dipole moment, it is as per the direction of the incident wave. Now, this dipole moment, it produces an electromagnetic waves. And this electromagnetic wave, it is called as polarization wave. So when light is propagated through dielectric, then it is said to be polarized. For example, when dielectric is placed between the charge plate of a capacitor, then the polarization vector p, it is directed towards electric field, or we can say that it is directly proportional to the electric field. It is given by this equation, that is polarization vector p equals to epsilon 0 into chi into e, where p is the polarization vector p, epsilon 0 is the permittivity of the free space, and chi is the susceptibility of the medium, where E is the electric field. Now, from this equation, we can say that if electric field intensity increases, then polarization also increases. When a graph is plotted between this polarization vector P and electric field E, then a straight line was obtained. And the material which exhibits such type of relation, it is called as a linear dielectric. In linear dielectric, stronger the electric field, greater will be the polarization. That's why these materials are called as a linear dielectric. The material which obeys such a linear relationship between the polarization and the net electric field, that's why it is called as a dielectric material. Now, when such electric field, when it is propagated through dielectric field, then it polarizes the medium. That's why the optical parameter of dielectric they are closely related to the dielectric polarization. So its refractive index, it is given by under root of epsilon. Now, as long as the intensity are small, optical parameter are constant and independent on the intensity of light. Because here, ordinary light generate a radiation, which is in the range of 10 to the power 5 volt per meter, which is very small as compared to atomic field dimension. That's why whenever intensity is small, then the emitted wave have the same frequency as that of the incident one. So as long the intensity is small, it does not affect any optical parameter. So this chi or this epsilon or the refractive index of that optical medium, or we can say that in one word, that is the optical parameter. They are constant and they are independent on the intensity of the light. Now, second is non-linear polarization. The material in which polarization exhibits non-linear dependence on the field strength are called as a non-linear media. Now we know that at low intensity, polarization is proportional to electric field. But from the figure, it is clear that as soon as the intensity of electric field increases, the polarization cannot be increases linearly. It is expected that it cannot increases linearly. After some times, it becomes saturated. If it is saturated, it means that it shows the non-linear behavior. So that's why the material which shows a non-linearity in the medium of the polarization with respect and which depend upon the electric field, it is called as non-linear polarization. When a high electric field is used, the polarization cannot increases linearly. So we may anticipate this is the non-linear behavior of the polarization. But but how this is non-linear? Because here laser generated a radiation which is in the order of 10 to the power 7 to 10 to the power 11 volt per meter. This radiation is large. It is equal to the atomic field dimension. Means here the nature of the light is very intense, and due to this intense nature of light, the polarization responds non-linearly to the electric field. We know that if intensity is high, then it affect the optical parameter. So that's why in next sentence I write there, when the intensity is very high, then optical parameter becomes the function of electric field. Whenever a very high intense light propagates through medium, then it affect the optical parameter, and sometimes this optical parameters becomes the function of such high electric field. Now suppose if medium is isotropic and light is propagated through that isotropic medium. If the light has very high intense ratio, then the direction of polarization vector and the direction of electric field, in case of isotropic medium, they coincide with each other. And this chi of E, it can be considered as a power series in the field strength. So it is given by chi of E equals to chi1 plus chi2E plus chi3 EQ. So this is the power series of the electric field. When this electric field propagates through isotropic medium, then the polarization produced due to such electric field, which is given by next equation. So here, the chi1 is the linear susceptibility, and other this chi2, chi3, and so on. They are a non-linear coefficient. It is point to note that one point is noted that these non-linear coefficient, their contribution, it is due to the large amplitude high electric field, where chi1 is the linear susceptibility and it is larger as compared to this other nonlinear coefficient. So from this, we get our second order nonlinear polarization and third order nonlinear polarization. So we can say that this non-polarization, it leads to the nonlinear optical effect. Next is when such high electric field of radiation is incident on medium, then any mediums becomes linear. Because due to intense nature of the light, when an intense light, when it is propagated through medium, then polarization responds non-linearly. So we can say that any medium, when it is exposed with a high light, then it becomes non-linear. And with the adventure of this now intense laser systems, the non-linear polarization assume importance. Means it is possible to generate a frequency with a dual property, or many other optical effects can also produce with the help of this intense laser system. For that, suppose if we consider one electric field oscillation. Now such electric field oscillation in terms of wave, for this we can write one equation, that is E equal to E0 sine omega t. When such electric field propagates through media, then we know that the array of dipole is produced in that moment, and that array of dipole produces an electromagnetic wave, which is called as a polarization wave. So this polarization caused due to this wave, it is expressed in terms of this equation. This above equation we can written as the last equation. Here the first term is a linear successibility, and as we go towards the equation, their power are high. Means in case of linear dielectric, when linear dielectric means when intensity is small, then the polarization wave has the same frequency or same intensity as that of incident light. Whenever a light is incident, light of small frequency, when such a small frequency light is incident on the medium, then when small light intensity is incident on the media, then we get the polarized light having the same frequency and same intensity as that of. But as higher order, it means the intensity is high, and when intensity is high, then polarization wave of higher frequency is produced. So we have to describe, or we have to determine that phases in order to determine the enhanced frequency. For that, one most important nonlinear optical process is second harmonic generation. Now see that whenever a high intense light is fall on an anisotropic material, then it affects the optical parameters. Or we know that optical parameter depend upon the intensity. So in case of anisotropic material, when an electric field propagates through it, then the causes polarization is given by this. But here we see that this polarization, it consists of two components. One is linear polarization, second is non-linear polarization. Now, see that this is the non-linear response medium, in which symmetrical electric field shows unsymmetric polarization. This is the Fourier analysis of a symmetric polarization wave, which consists of a frequency mu and twice mu, as well as the DC components. Okay. Now, in order to understand the frequency concept, let us consider, suppose there is a plane monochromatic wave having particular frequency mu. If this monochromatic light wave, if it is traveling with a velocity v1 in a non-linear medium, then the electric field of the wave, it may get this form. If you see the equation, then I highlight one term in that equation, that is 4 pi v. This 4 pi v term, it belongs to the wave which is propagated with the same velocity along the same direction, but it is different in terms of frequency because it has a dual frequency response. It means that if there is a possibility that when an incident light propagated through medium, then it can generate a second wave with a higher frequency. It means that this is a second wave, second harmonic wave. That's why it is called as a second harmonic generation. If first wave having a frequency, it is propagated through the medium, then after propagation, it generates a second wave with a dual frequency. So this property, it is called as a second harmonic generation. Now this both wave, means fundamental wave and the generated wave, they can combine together. They can combine constructively, but they have to satisfy the phase matching condition. Now first, the incident wave, it is considered as a pump wave, which is very intense. That's why it is called as a pump wave. And the second generated wave, it is called as a second harmonic wave. Now, if we calculate the ratio of this second harmonic wave to the pump wave, then it is found that this ratio is depend upon the phase mismatch factor. And the phase mismatch factor, it is denoted by delta k, where this is the equation of delta k. Now, one more important is notice that in order to get very intense second harmonic wave, if you want the second harmonic wave generated to be more intense, then one has to achieve this delta k equals to 0. If the delta k equals to 0, then it follows the equation, and that equation is called as phase matching condition. It is also called as index matching condition. This is suitable for that material. But when the pump wave and when the second harmonic wave, they have the orthogonal polarization. Actually, this phase matching condition, it is not for a general, it is only for the anisotropic material. So this is the phase matching condition. And now there are two diagrams. First diagram shows the arrangement of the second harmonic generation, and second diagram is the standpoint concept of the photon. Now, if we see the first diagram, see carefully that diagram. The second harmonic generation arrangement is there. This arrangement consists of two uniaxial double refracting crystal surface. Both crystals are uniaxial. Their refracting surface are double crystal, and which exhibits a non-linear material succibility. Second point is both crystal, they are cutted in a rectangular parallelogram along with its axis along the direction of the phase direction. Okay, the light which is generated from the laser, it must be incident, means it must be a plane polarized light, and this plane polarized light, it is perpendicular to the principal section of that crystal. Once this setup is done, then when a light from this laser, it is emitted or it is incident on the crystal, then it continuously generates a second wave, which is called as a second harmonic. That's why this whole concept is called as a second harmonic generation. With the help of this second harmonic generation, the frequency doubling phenomenon was possible. Is possible, not was, is possible. Second diagram shows the standpoint concept of the photon. We know that according to quantum mechanics, light is considered a photon. It is considered as a photon, and energy of each photon is h. Now, from the figure, we can say that on the left side, we have seen that there are two photons having their fundamental frequency. They destroy or they add together, and at the right side, one photon with higher frequencies generated. So this is the concept of a standpoint. We can call it as a standpoint concept, because here two photons having their fundamental frequency, they add it together, and after addition, a high frequency photon is generated there. So this is the standpoint concept of the photon. Now, there is one commonly used material for this second harmonic generation, which is commonly used material is KDP crystal. But actually, it is a negative double refracting crystal, because here in negative crystal, because there are two types of crystal. In positive crystal, fundamental wave is considered as ordinary wave, while the second harmonic wave, it is considered as extraordinary case. But in case of a negative crystal, fundamental wave, it is considered as ordinary wave, and secondary wave, it is called as extraordinary. Secondary harmonic wave, it can be considered as an extraordinary wave. So this is the concept of second harmonic generation. It was first actually demonstrated by Frankel and his co-workers in 1961. And actually, it is used to extend the wavelength region of the lasers in UV region of the spectrum. Next is phase matching. Now, we have already know that it is all about the light. It only depend upon, the fact is depend upon the frequency. If a frequency is high, then the polarization wave produced with the high frequency. And if frequency is low, then polarization wave produced with the low frequency. Because when an electric field propagates through any medium, then it allows some forces throughout that medium. But these forces are very small in nature. That's why they induces dipole moment. And the array of dipole producing an electromagnetic wave, which we called as the polarization wave. The polarization wave, it all depends upon frequency. If the intensity is small, then polarization wave of a same intensity has been produced. So, since the optical media are dispersive, the fundamental and harmonic signals have different propagation spread inside the media, and the harmonic signal generated at different points there interfere destructively with each other. Now, to understand the condition of which the enhanced frequency, because we get two waves. One is fundamental, second is the second harmonic wave. The principal wave we can call it as a pump wave. Now, they can combine together but they have to match the phase matching condition. Actually, the direction of a generated wave, it is coincide with the direction of the principal wave, while its plane is perpendicular to the plane of the incident one. To understand the concept of this enhanced frequency, we have to consider one polarization wave and one second harmonic wave. Suppose this polarization wave, it is propagated with a velocity v1. Then it is given by v1 is equal to this. That is equation number 1. And the generated wave is called as a second harmonic wave. When such a second harmonic wave, when it is propagated through velocity v2, then it is given by equation number 2. If we see these two equations, then it is found that this equation number second is different from first in terms of frequency. Why? Because here the refractive index, it is the function of the frequency. Because whenever a light is incident on the medium, then molecule from that medium, it absorbs the energy of that incident. So there must be efficient transfer of the energy. And for such efficient transfer of energy, it follows the next equation. But this next equation, it is similarly to the phase matching condition. But I have already said that this is not for general. It is only for the anisotropic crystal, because this phase matching condition is satisfied when the principal wave and the second harmonic wave, when they have the orthogonal polarization. Now, in this case, when we know that we already seen this in some frequency generation, two light photon they add together and we get a high energy photon. Here, when refractive index of first light, that is plane polarized wave, and second polarized wave, when it is propagated through a media, then the light is split into two rays. First is ordinary ray and second is a extraordinary. Now, this ordinary ray, it is represented by O rays. See there, this is the index matching figure. In that index matching figure, the ordinary wave, that is O ray, it is represented by O ray, and the extraordinary wave, it is represented by E. Because whenever a high intense electric light, when it is propagated through a uniaxial crystal, then that crystal split up this light into two rays. One is ordinary ray and second is extraordinary ray. Now, the refractive index for this ordinary ray have circular surface, while the refractive index for this extraordinary ray have ellipsoid structure. Suppose the refractive index of an ordinary wave having frequency mu, and the refractive index of extraordinary wave having frequency twice mu. When they interact with each other, then they intersect at a point P. Means P is the point of consideration. P is the point of consideration where velocity v1 equals to velocity v2. When their velocity are equal, then we can say that they satisfy their phase matching condition, or we can call them as index matching condition. Now, what is sum and what is difference frequency generation? When a light waves have a different frequency, then suppose light have a different frequency, more than one wave having different frequency. If they propagate through media, then in a non-linear crystal, make it possible to generate a beam which produces a sum of frequency and a difference frequency. Means, consider one light. Suppose one light has a frequency mu1 and another light has a frequency mu2. When both lights are made to interfere with the non-linear crystal, then non-linear crystal generate a beam having a frequency either mu1 plus mu2 or mu1 minus mu2. So, because of this, the frequency doubling concept of the second harmonic generation, it is analysis in this sum and difference frequency generation. For explanation, suppose consider two coherent waves of a frequency mu1 and mu2. When it is propagating through the medium, then first wave, it is represented by the equation that is E1 sine twice by V t, and second wave is represented by the equation E2 sine twice by V2 into t. Due to superposition, Due to phase matching condition and due to superposition, we can add them. When they add them and this electric field, when it is propagated through medium, then the polarization caused due to this wave, it is given by epsilon 0 into chi2 into E square. When we substitute the value of E in above equation, we get this non-linear polarization. Now, this is the expression for non-linear polarization, which shows a dual frequency, that is twice mu1, sum of frequency, that is mu1 plus mu, and minus, that is a difference frequency, that is mu1 minus mu. Now, they are not simultaneously generated. It is important to note that these are the additional frequencies, one sum frequency, one a difference frequency, and one dual frequency. It can generate in its output, but they are not generated simultaneously because phase matching has to be satisfied. And it is important to note that in these phase matching, it is only implemented to only one frequency at only one time. Means there are additional frequency, but phase matching is implemented to only one frequency at particular one time. Uh, these are the standpoint concept. Now, in figure A shows the sum frequency generation, while figure B is the difference frequency generation. Now, in figure A, there are two photons having a fundamental frequency mu1 and mu2. They are destroyed and one high frequency photon is generated. In a difference frequency generation, even high photon is applied to the non-linear material, then it is destroyed and two frequencies are created. Here, mu2 is used as a one of the input of the frequency. So in this process, this mu2 is amplified, so it is considered as a Prof. So this is the concept of sum and difference frequency generation. Actually, it is used to detect the radiation. Because, for example, one light is generated from CO2 laser, having a wavelength suppose 10.6 micrometer. And second light is generated from ND-AD laser, having a wavelength 1.06 meter. When they made an interfere with each other, then generate a beam having a wavelength 0.964. So it is easy to detect a radiation at such wavelength. That's why this sum and difference frequency generation are used. And next is the parametric oscillations. Now, the production of coherent radiation at particular frequency in the ultraviolet region is very much essential. So, apart from the techniques we are using in harmonic generation, the frequency tuning by the parametric oscillation, it is also essential. Actually, this parametric oscillation, it is widely used in electronics. There, they made a non-linear capacitor. Now, in some frequency generation, where two photons are added together to get a new high energy photon. But here, high energy photon is applied to the non-linear material. Suppose if we take a crystal of lithium niobate crystal, given a strong beam of a particular frequency, that is mu1, when it is applied to a suitable non-linear material such as a lithium niobate, then two beams at lower frequency can be generated. So first of all, this medium is placed between two mirrors, which generates a resonant cavity, and that is must be comparable with the laser cavity. And in order to satisfy the phase matching condition, first the mu1, it is a strong, it is intense. That's why it is called as a pump wave. Whereas this mu2 is called as a signal wave and mu3 is called as an Adler wave. Now, if the value of mu1 is fixed, then the value of this mu2 and mu3, it can be varied. And by variation in the crystal, its value almost varies. So this is called as a parametric amplification. And if these two mirror, if they shows reflective at the signal wave or the Adler wave, then the resonance enhances the interaction of the optical parameters, which then the system is act as a parametric oscillations. So here frequency is tuned by using temperature control knob by the variation in the phase matching condition. So this is the concept of parametric oscillation. It is used to tune the frequency. Actually, there are two methods. We can vary the phase matching condition by tuning angle and the temperature. Next is the self-focusing of light. Now, see that laser beam has a Gaussian intensity profile. It can induce a Gaussian refractive index profile inside the analog sample. The physical mechanism is based on a core non-linearity with positive right. Now, whenever an electric field propagates through medium, then it affects the optical parameter of that medium. We know that if the nature is intense, then it will affect the optical parameter. That is, it alters the density, it changes the refractive index. Means if the intensity has a Gaussian beam cross section, then its intensity would be maximum on the axis. The content of the refraction or the index of the refraction would be maximum on the axis, which causes the refractive index behave like the medium behave as a function as a beam as a lens, and the beam contracts and then it gets result. So that's why this is called as a self-focusing of light. One of the most important nonlinear optical process to generate a radiation is known as a stimulated Raman scattering. Now, this can be described from the standpoint concept of the photon. Now, if we see in this process, then optical medium absorbs high energy photon and it emits lower energy photon. At the same time, simultaneously, it absorbs the balance energy of the photon and then it goes to the excited state. Means when a photon is incident on the material, then the molecule from that material it absorbs the energy of the photon and then it goes to the excited state. Now, the normal Raman scattering produces or generated uncoherent radiation, while this is stimulated Raman scattering, it generates coherent radiation. And the parametric amplification, it enhances the stimulated Raman scattering. Now, when light is incident through that non-linear medium, then radiation will be scattered in all the direction. When the scattered radiation is recorded or when it is photographed on a color sensitive film, then it was found that the additional wavelength, Stokes lines and anti-Stokes lines are well emitted, because here the additional wavelength, they are well collimated with the laser beam and they are coherent in nature. Next is the Stokes lines. Stokes lines which are present at the lower wavelength number, they are along the direction of the laser beam. And last is the anti-Stokes line. Anti-Stokes lines, they are present at upper wave number. They make a specific angle with respect to the direction of the laser beam. Now, next is the power transfer to the Stokes line increases with the increase in the power, because power of laser is transferred to the first line. When first Stokes line becomes intense, then the power from first line it is transferred to the second line, and then this first Stokes line it is act as a source, and similarly it goes on. So there is no need for inverting population of the stem, because this is the one difference. This is the most essential difference of stimulated Raman scattering and stimulated emission in the laser, is that for generating the coherent radiation, there is no need for the inverting population of the states. So this is the most important. Actually, it is associated with the active media, means it imposes their own characteristic frequency. Last is that this is my last slide, the application of nonlinear optics. So in this way, the optical wave manipulation is one of the future technology for the optical processing. It has various applications in fiber optic communications and optoelectronics, which make it an increasingly important topic among electrical engineers. Fiber optic communication means to transfer information from one place to another. And optoelectronics means this is the subfield of the electronics or photonics. Okay, it is used to source the electronic devices. Then third is it is also used in optical phase conjugation, because in a normal mirror, when light is incident, we know that as per the Bragg's law, the angle of incidence equal to angle of reflection. But according to this optical phase conjugation, the light reflect exactly the same way as it is propagated. The next is the optical parametric oscillator. We have seen that tune frequency can be varied with the help of optical parametric oscillator. They are widely used in electronics. Then optical computing, optical switching, they are used in the network system as a bridge network system, as a port network system. It is used for optical data storage, the data imaging, digital imaging. So in this way, it is also used in photonics industry. So on my last note, I have to say one quote of C.V. Raman sir, the legendary C.V. Raman sir, that is, I am the master of my failure. If I never fail, how will I ever learn? Thank you all for patience listening. Actually, it was a network problem, so sorry for that. And thank you once again, Ajay. Thank you, Ajay, for making me agreeing this of such huge lecture. Thank you so much.
Well, thank you, sir. It was a wonderful lecture. Now the meeting is open for question answer session. If students have any questions, then they can raise their hand. I will unmute them from here. Kharat sir, is there any question on YouTube? Hello, Kharat sir.
No questions are on YouTube.
Okay,
No
okay,
questions are on YouTube, sir.
okay. So there are no questions from the participant side. It means that the topics are clear to the students. Now I welcome to the convener of this program and my colleague, Dr. Prashant Kharat sir, to present a vote of thanks. Over to you, Kharat sir.
Thank you, sir, for delivering this wonderful lecture. Myself, Dr. Prashant Kharat, and I'm here to present the vote of thanks for today's lecture of this lecture series, Sir C.V. Raman lecture series. I would like to thank our today's guest speaker, Professor Rohan Shirzad sir, for enlightening us with his profound knowledge. His lecture was full of knowledge and interesting things. It has given a deep insight into the topic and also revealed that some interesting facts. The point where Sir told about the importance of non-linear optics are very informative. I'm pretty sure that the precise knowledge of Mr. Rohan Shisa sir will definitely help our student for their bright future. I would like to thank you, sir, uh, for giving us valuable time from his extremely busy schedule. Thank you so much, sir. We are glad that you have here. I also thankful to the all the students for paying their attention and learning. Well, I would like to announce that tomorrow's lecture will be conducted by the Professor Kalyani Atram Madam. Ma'am works as an assistant professor in the Department of Physics at Anand Niketan College, Science, Arts and Commerce, Warora, District Chandrapur. In her lecture, ma'am will going to tell us about lasers, and it is really going to be interesting lecture. Well, here I declare that today's session will conclude it, and thank you, sir. Thank you very
Thank you
much
so
for
much.
all.
Thank you, Shirzad sir.
Thank you so much.
Thank you. Thank you.